Hello everyone, and thank you for joining us today to learn more about Infineta's Data Mobility Switch, the DMS, and how the DMS is the ideal solution to accelerate enterprise data protection. My name is Haseeb Budhani. I am the Vice President of Products here at Infineta. I will briefly cover some enterprise pain points and technology trends, identify a few common use cases that we see in customer environments regularly, discuss a few highlights of the DMS, and how it is being used by customers to accelerate data protection. Businesses are investing considerable resources to adopt strategies to speed up business processes. Their goals are minimizing time to recovery and optimizing their overall infrastructures. Business initiatives tend to lead to IT initiatives such as business continuity, data center consolidation, virtualization, and big data adoption. For all of these initiatives, the WAN, the wide area network, is the key element. The inter-data center WAN is clearly at its breaking point. The typical inter-data center WAN is too small for enterprises, and enterprises really continue to deploy WANs that are a fraction of the speed of their data center LAN. When IT initiatives come to a head and enterprises decide to upgrade their WANs, they face yet another challenge. WAN upgrades are expensive and time-consuming, and enterprises are forever playing catch-up to the needs of key business initiatives such as replication, which, by the way, grows continuously year over year. It's growing at 45%. As a result, WAN resources are allocated in a tiered fashion, with some initiatives always left wanting of resources. Even in cases where enterprises are able to allocate a significant portion of their IT budget to bandwidth expenditures, the data center distance between data centers and really the quality of the WAN link, for example, if MPLS is in play, tend to play havoc on application performance, effectively defeating the value add of the bandwidth upgrade. Let's take a look at a few use cases where performance is significantly limited due to the WAN-specific constraints that I've just discussed. So a large financial services company situated data centers on the east and west coasts of the continental US. The company's storage architects determined that basically the distance between the data centers would provide complete protection if a major disaster were to strike. And they put together a very comprehensive storage replication project in place to meet their goals. The company deployed 10 gigabit links, and multiple of them, by the way, I believe up to 4 10 gigabit links between 2 sites in an effort to make enough bandwidth available to meet all data protection needs. Unfortunately, the company was unable to meet RPO or RTO goals, even though they had clearly abundant bandwidth in place. In fact, replication was actually breaking down. So replication flows were periodically timing out because of the high WAN latency. So the latency impact basically made the WAN bandwidth upgrade completely useless, since the existing solutions were unable to fill the WAN link over anything over 20–25%. Let's consider a multinational deployment where Oracle Data Guard is being used to protect records for internal and external customers. So this company provisioned MPLS links between all its data centers, and they had a minimum of 2 1 gig MPLS links for all data centers meshed together. And the intent was to provide database replication across sites. So this company ran into 2 issues. One, in some cases, 2 to 3 gigabit was simply not enough to meet the needs for all the traffic being generated because of replication. And in other cases, given the distances, the company was basically only able to utilize 20 to 30% of the WAN. So this company basically, could not meet its SLA, advertised SLAs to any of its customers, be they internal or external, because either they did not have enough bandwidth available, or the distance between the data centers was too large. Finally, let's look at a very simple file transfer use case across the Atlantic. A very large enterprise generated close to about 10 terabytes a day that it needed to transport to London from New York during the course of the day. Even with 10 gigabit of available WAN capacity, the utilization on the WAN was extremely poor, and the enterprise was essentially never able to complete the 10 terabyte cycle in any given day. This customer also tried tuning the TCP stacks on the endpoint servers, but that didn't help either. In fact, in many cases, it made things worse by tuning the endpoint TCP stacks. So Infineta's Data Mobility Switch, the DMS, is really the only WAN optimization solution designed to address all of these use cases that we just discussed. The DMS has been architected using merchant silicon. This high-performance networking approach to system design, along with multiple patent-pending data reduction algorithms, are what enable the DMS to scale to 10 gigabit speeds without any loss in performance efficacy. The DMS can deliver 5 to 10x data reduction for any enterprise WAN traffic, can generate priorities and guarantee priorities for critical traffic, can be transparently deployed in any data center network in minutes, and deliver a full return on investment to customers in well under 12 months. The DMS exposes 3 distinct feature sets: control, optimize, and reduce. Control entails identifying the traffic that the customer would like to accelerate, prioritize it based on business policies, and ensure minimum and maximum performance guarantees for all select traffic in the network. The optimized feature set allows the DMS to accelerate a single flow at up to 1 gigabit rates. Given the unique congestion control algorithms that the DMS has been equipped with, it can effectively fill a 10 gigabit link with as few as 10 flows, be they TCP or UDP, at any distance. No other WAN optimization solution is able to scale this well at such high speeds. The reduction feature set consists of 3 engines: repeat byte suppression, deduplication, and compression. All of these are implemented in merchant silicon and are guaranteed to not falter when the input speeds go up. The repeat byte suppression engine suppresses all repeating bytes in hardware at line rate and simply passes along a reference for the repeating bytes to the next engine. And the next engine is the velocity dedupe engine, which carries out network deduplication on all received traffic. The velocity dedupe engine is the company's crown jewel and is able to dedupe traffic at 10 gigabit input rates at very low latencies, typically in the tens of microseconds. Finally, before packets leave the system, they are opportunistically compressed to get further reduction at high speeds. So given the unique architecture and the feature sets that the DMS carries, it is superior to the leading competitive solution on a number of fronts. Not only does the DMS offer a 5x performance advantage in terms of sheer throughput, it also delivers the highest per connection throughput in the industry and orders of magnitude lower port-to-port latencies than the competition. But perhaps most importantly, the DMS delivers the most value to the enterprise of any WAN optimization in terms of CapEx. Also, the DMS requires a fraction of the power needed by other WAN optimization solutions. So now let's return to the use cases we discussed previously, and let's see how the DMS address customer needs in each of them. So for the coast-to-coast high-speed replication use case, the DMS was able to reduce WAN traffic by 78% and increase effective WAN capacity by about 5x. But most importantly for the customer, the thing that moved the needle for the customer was the fact that they were now able to carry out replication without any issues. It wasn't timing out anymore. And they were able to reduce their RPOs by 60%. And that's what the decision factor happened to be. For the multinational Oracle Data Guard use case, the DMS delivered more than 10x performance improvement, with data reduction accounting for 3x of the performance. For the cases where there was not enough bandwidth available, customers were able to push 3 to 5 times more traffic. For the cases where latency was a problem, customers were able to effectively improve performance by up to 10 times. The customer was finally able to advertise and commit a meaningful SLA to its internal and external customers, and again, in this case, that was the decision factor for the customer. So for the transatlantic use case, the customer witnessed actually a whopping 60% improvement in performance because of the DMS. The customer only ended up using 2 gig of the 10 gig WAN, and the remainder 80% they utilized for other purposes. Without the DMS, they would have ended up buying more bandwidth, and of course, they would never have met their goals of pushing 10 terabytes across the Atlantic in a given day. So as you've discussed today, the DMS is the ideal solution to accelerate enterprise data protection initiatives and is the best suited optimization solution for inter-data center WANs. I'm happy to take some questions at this point from the audience. So if you have questions, please submit them via the chat facility built into the GoToWebinar client. And we'll pick a few questions and maybe 4 or 5 questions given the time, and we'll address them immediately. Okay, so it looks like there's a few questions lining up here, so I'm just going to pick the first one. What is the smallest WAN link supported by the DMS? Okay, so the DMS scales, anywhere from a gig to 10 gig speeds. So 1 gigabit, 10 gigabit, same system will do it. So really it can be deployed anywhere from an OC3 to a 10 gig link. One OC3, a couple of them, all the way to 10 gig link, the same DMS is going to be fun. And given the fact that the system's performance actually can be increased via license. So you can deploy, for example, a 2 gigabit DMS today, and tomorrow when your data protection needs grow and you need, say, 5 gigabit licenses, it's a simple software license. You do not need to do any forklift upgrades, which makes life very, very easy, because at the end of the day, I mean, the fact that data is growing, it's going to happen, right? So you have to be ready now and build in the protection and the protection for investment. Okay, so next question is, what deployment types are supported by the DMS? So, given the fact that we have taken a very networking device approach to designing WAN optimization here at Infineta, the deployment options that the DMS provides are pretty flexible. And because of the architecture, not only can the DMS be deployed on a path, which is true for everybody, it can actually sit inline in your data center on a 10 gig trunk, something that no other WAN optimization solution can do. Okay, next question is, do you accelerate branch traffic? So sure, if there's any branch traffic being backhauled between data centers, absolutely, we'll accelerate that quite well, actually. But our focus really is on inter-data center WAN links. I mean, we chose early on to really kind of focus and be the best at one thing as a first step. I mean, other vendors, I mean, there are many of them who kind of try to be everything to everybody. So they do branch, they do virtual machines, they do data center. I mean, such approaches dilute your focus and you end up being not good at anything. So that's not what we do. We focus solely on the inter-data center WAN here at Infineta. Okay, let's do 2 more questions, short. So, okay, next question is, we use Cisco MDS for SAN extension. Can you help with this scenario? Yeah, absolutely. So Cisco MDS or Brocade for that matter. I mean, we see this all the time in financial services customers. We've been doing a pretty good job of accelerating the FCIB tunnels between these devices. In fact, we built in support for jumbo frames, particularly to address FCIB use cases. And as I understand it, Cisco MDS, the suggested MTU for Cisco MDS is about 3,000 bytes. So we will be just fine in those scenarios, and you do not need to worry about fragmenting your SAN frames across the WAN. Okay, one more question. Let's make this the final one. What is the impact on traffic that is passing through the DMS but is not being accelerated? Okay, so that can certainly happen. If you deploy in line, it's quite likely that you'll see some traffic that you really don't want to accelerate. Let's say you're backhauling VoIP traffic between data centers or across a big link between data centers. We call that bypass traffic. You can configure the system to ignore certain traffic, and when you do that, so bypass traffic is actually switched out of the system, and it doesn't happen at the data plane or the control plane. It happens at the backplane level. So the overhead, packet comes in, packet goes out. It's no more than 2 microseconds. So 2 microseconds. So effectively a rounding error. And we see this a number of times. Particularly with sometimes the VoIP traffic. In other cases, we've seen some MPEG type traffic being pushed across the WAN, and customers choose to not accelerate that traffic, which is fine. And in some cases, they actually choose to give that traffic highest priority, particularly if it's VoIP traffic, so that no other traffic gets in the way. So looks like we're out of time. Thank you so much for attending today. We are available via email or phone to answer any of your questions, and there are some links on the screen there that you can click on and get in touch with us or learn more about us. All our contact information is also available on the website, infineta.com. We look forward to continuing this conversation with you soon. We'll be in touch, and of course, you can get in touch with us as well. Thank you again, and have a good rest of the day.